Hello and welcome. Today we're going to be looking at the key features of graphs. This is another topic as part of the problem solving and data analysis of the SAT math portion. And as always, we're going to be looking at 5 questions, explaining them to look at the intricacies of this topic to help you ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here it is. All right, so we're given a bar graph of the US DVD sales in billions of dollars versus the year from 2007 to 2012. And we're told that compared to the sales in 2007, US DVD sales had declined by about 45% by which of the following years? So sales in 2007 are, if I'm going to estimate it, I would say around 15.8 or 15.9. And then 45% decline, which is going to be a 55% staying, so times 0.55, is going to be around 8.69, so around 8.7. And we need to find which one of these bars is around 8.7, which is that was a horrible line, which is around right here. And it's kind of clear that it's going to be this one right here, 2010. So we look down and 2010 is our answer, 2010. And let's move on to the next question. All right. Let's see what we have. We have international box office by region in billions of dollars versus year. In Europe, Middle East, and Africa, for the gray, Asia Pacific for the white, and Latin America for the black. All right, the figure above shows the international box office by region in billion dollars, 2014 to 2018. Based on the figure, which of the following statements are true? In Asia Pacific, the box office increased by more than 30% from 2014 to 2018. While Asia Pacific, we started from around 12, right? 12. An increase in 30% is times 1.3, and that's going to be around 15.6. It's at 16 right now, so that is true. So 16 is true. 16 is true. All right, now what? Well, the second one is in each of the 3 regions, the box office increased from 2014 to 2018. In Europe, Middle East, and Africa, it actually kind of went down. Asia Pacific, it went up, but in Latin America, it also kind of stayed stagnant, maybe it went a bit down. So 2 is going to be wrong. 2 is wrong. All right, now let's look at the last one, which is the combined box office of all 3 regions increased from 2014 to 2018. The combined box office, well, in the beginning, we have around 12, a little bit more than 10, and a little bit more than 2. So 2 plus 12 plus 10 is going to be 24, and then a little bit more, so maybe 25 or 26. At the end, we have a little less than 10, a little more than 16, and then a little more than 2, which is going to be around 28, maybe plus or minus 1. So that is going to be more than the 26 we started with. So then this is also going to be true. So 1 and 3 are true. So our answer then is going to be answer choice C right here. So that's our answer. And let's move on to the next question. All right. So the next question, we have peregrine falcons in Canada, number of occupied sites versus year from 1990 to 2010, going by 5 years at a time. The bar graph, and we're asked by approximately what percent did the number of occupied sites increase from 1990 to 2010? Started at 300, we ended up at 600, so we doubled. So we had a 100% increase, which is doubling. And let's move on to the next question. All right. Here we're given a scatter plot of the revenue in thousands of dollars from months since January 1st. And we're told that the graph at left in the TR plane shows the cumulative revenue R in thousands of dollars earned by a snow sports equipment company T months into the year. What is the best interpretation of the difference in the average rate of change between the first and second halves of the year? Well, let's see. So all 4 of the answer choices say they earned an average, or the first 2 answer choices say they earned an average of 158,333 more per month or less per month in the second half of the year than the first. The other 2 say 296,000 more per month in the second half and 296,000 less per month in the second half. Well, let's see. So this is the revenue. We're trying to find essentially that revenue, and we're asking for the average rate of change between the first and second halves of the year. Well, let's see what we can do. Well, we're given a graph of the revenue in various months, and we're trying to find the whole thing. So if you're familiar with calculus, you might recognize it as a kind of integral, but we don't need an integral to solve this. You won't find calculus on the SAT in any case. Right, so we can split that between the first and the second halves. Right, so everything in this first half is in, oops, everything in this first half is in green. That's the revenue for the first half, and the second half revenue is in red. And it should be noted kind of clearly that the second half has a lot more revenue than the first half. But let's see how we use this graph, we use this information in the question. So let's look at our answer choices. Trying to earn an average more per month in the second half than the first. Well, what is our average value? Let's think about that. Well, let us see. In the second half, our average seems to be around what? Our average seems to be maybe like right there, somewhere around that, like here or here. This is where our average is, so something like this. So when we look at this, this is around 2,250, which is going to be 2,250,000. And then for the other end, the average is going to be around like right here, right here, right? That's where we see the average in here. And that's going to be around 750 million or 750,000. So the difference here between those two is going to be around what? Let's see. Well, the difference here is going to be what? 1.5 million, which is a lot more than what we've seen. So let's try that again. Let's try this question again. Because obviously we messed up somewhere. All right, let's see. So the difference in the average rate of change between the first and second halves of the year. Okay, what we got? The snow sports company earned an average of 100. Okay, so I think we can all agree here, looking at the graph, that we earned more in the second half than the first half. Like that is kind of a given. We can see that, which means that the choice B, which says we earned less in the second half, and choice D, which says we earned less in the second half, are both wrong, and we can get rid of those. So either we earned 150,000 more per month in the second half, or we earned 300,000 more per month in the second half of the year than the first half of the year. And we need to figure out which one it is. All right, let us think about how we're going to approach this problem. The first and the second halves of the year. So in the first half of the year, how much did we earn on average? Well, if we were to find the area under the curve of the first half, we would get something that looks like this. Right? And if you're not familiar with that term, the area under the curve is going to be the amount of, it's like an antiderivative, but if you don't know calculus, it's going to be the amount of revenue total, right? So since we're given the revenue in thousands of dollars for like each month, then finding the area under the curve is going to be that total revenue that for all those months. And then right here for this, we have what kind of looks like. Draw a line here, here. Something that roughly looks like that. All right, and we can section that off to call up into a couple parts. And we can see here that this part is going to, oops, okay. This part is going to equal this part, but then there's this whole other part of more stuff over here that's going to way overshadow that. All right, but how much overshadow? That's really what we're trying to find out here. Well, we have right here, we have what? We have, let's say around, this is around 100 or 1250, so around 1,250, that's $1,000, so that's around 1.2 million. Right, so 1.2 million, that much is around extra for those 3 months. So if we're trying to find the total, that would be 1.2 million times 3, and then we have to divide by 12 for the number of months. So if we divide by 400, it would be around $300,000. So our answer then would seem to be choice C, around $300,000. This question did seem extremely difficult, and that's why we need to make sure that we can check for both of all of these answers, right? And we can see how we can do this, right? So you can see in this here, this is the average rate of change of the entire year, right? This isn't just finding the rate of change. This is finding this, essentially, this line right here, from the beginning down to here. That's what we found. Like a 3.5 million over the 12, and you're going to get that $296,000. That's the average rate of change for the entire year. We're trying to find something more like this, right? Something more like this, right? And then you get $158,000, and that's why choice A is correct. Let's move on to the next question. All right, question number 5, here we are. Electrical activity in volts versus time in seconds. What do we have here? A doctor observes the graph above, which shows the electrical activity in volts of the heart of a patient over a period of time in seconds. Each local maximum of 0.04 volts corresponds to 1 heartbeat. What is the heart rate of this patient in heartbeats per minute? Well, let's see. So in this graph, starting from 0, which is right here, to, let's say, where can we find something? We can look at 2, we can look at 4, we can look at 6. We see that after 2, we have 1, 2, 3 heartbeats. So we have 2 seconds, 3 heartbeats. So after 60 seconds, the whole minute, we're going to have 3 halves times 60, which is just going to be 90 heartbeats. So our answer was going to be 90 heartbeats per minute. And we're done with this topic. As you can see, this whole topic is just about taking graphs, taking scatter plots, and analyzing them, trying to find the key information that there is in these. That's all there is to it. We're just taking these and we're analyzing it. That is it for this topic, and I'll see you next time.